I've never seen a diamond in the flesh.
Quantities often change over time, such as a balloon being inflated by air, its volume increasing in a constant way given that the rate of the air at which the balloon is inflated is constant too. When a quantity is changed, it can be changed according to time. When a runner is leaving the track at 10 km per hour, the distance is changing every hour. This is a related change. The distance relates to the time. As the time passes, the distance becomes greater. In calculus, we use this to know the related change of rates of whatever it is we want to find. When we derive a function and want to know a related change, we relate the unknown value of the function in respect of time, being that the value changes as respect of time and is what we want to find. In the next problem, we will be seeing how to relate the distance between two objects and the speed at which they are distancing themselves.
You can call me Queen Bee, and baby I'll rule.
This is the problem, and the objective is to find the rate of change between the human and the helicopter after 5 seconds. Well, the objective of this problem is to find the rate of change between the helicopter and the human. Well, in this sketch, we can see the helicopter rising up, while the human is walking forward. And here we have the distance, that is the rate of change. For this, we're gonna need the Pythagorean formula, and from this one, we're gonna get the first derivative, which is 2c plus dc over dt. This part means the rate of change of the distance, c, which is related with time. And this one is the first derivative, which we are gonna use for this problem. Before this, we need the values of a and b, which we're gonna get with the data of the problem, which we have here. We're gonna use 25 times 5 and 10 feet times 5 that we're gonna get here for a and b. And after this, we have the data of this. We can substitute in these ones and isolate for dc over dt.
Well, the rate of helicopter is 25 feet per second. Then the rate of human is 10 feet per second. But we need to find the rate between helicopter and human. To find the rate between helicopter and human, we need to use the formula of Pythagoras, which is c squared equals a squared plus b squared. We need to derive the formula over time, which is 2c times dc over dt equals 2a times dA over dt plus 2b times dB over dt. Well, in this is the rate of helicopter and this is the rate of human. Then we need to replace the derivative with the rate of the things. So is 2c times dc over dt equals 2a times 25 plus 2b times 10. Well, we need to multiply 25 times 2a and 2b times 10 and isolate dc over dt. dc over dt equals 50A plus 20B over 2C.
As the problem requires that we find the related change after 5 seconds, we're gonna find the distance after 5 seconds of each, the helicopter and the human. For this, we're gonna multiply 5 times 25 and 5 times 10.
Raise your voice.
55 feet per second times 5 seconds equals 125 feet. 10 feet per second times 5 seconds equals 50 feet. Now we have the distances of both the helicopter and the human. In order to find C, we're going to replace this data in the Pythagorean formula, being C equals the square root of 125 squared plus 50 squared. This leading to C equals 25 square root of 29. Finally, to find the rate of change, we're going to replace all of this data into this formula. 20 times 50 plus 50 times 125, all of this over 2 times 25 square root of 29. This leading to dc over dt, or the rate of change of the distance between the helicopter and the human. The final result of dc over dt, or the rate of change of the distance between the human and the helicopter, is going to be 26.9258 feet per second.